Inequalities tonight.
Yes. Inequalities in two variables.
Okay. You wanna, is this stuff you can verbalize?
Yes.
Okay. Go ahead and give me the two or the single equation or inequality.
Okay, 2x plus 6y is less than 12.
Less than 0 or 2?
12.
12. Okay. And we want to graph that?
Yes.
Okay. First thing we want to do is figure out that that's a linear equation or inequality, excuse me.
Mm-hmm.
And so we can graph it as a line. Now, it's going to be a dotted line if this is just a less than. It's going to be a solid line if it's less than or equal to. But the first thing we need to do is figure out how to graph it. Now, there's a couple of ways to do that. Probably the easiest way is to put it into y equals mx plus b format.
Okay. The slope.
If I solve this left side of the equation for y, I get fix y is less than minus 2x plus 12. See that step?
I don't know. How did you get that?
I subtracted 2x from both sides.
Okay.
Okay? Now I'm going to divide both sides by 6. And that's going to give me y is less than minus 1/3 x plus 2. Make sure you understand how I got that.
Okay, how did you get the 1/3?
I divided negative 2 by 6, which is negative 2, which is,
That's just 3, right?
well, it's negative 1/3. In other words, if you have negative 2 divided by 6, I can divide top and bottom by 2, which gives me negative 1/3.
Okay.
All right?
Gotcha. Mm-hmm.
And then 12 divided by 6 is 2. In other words, when you divide the right side of this inequality by 6, you have to divide both pieces. Okay?
Okay.
Now I have it in the form of y is less than mx plus 2. Well, how do I graph that? Where do I start?
With the y-intercept?
Yeah, which is what?
2.
So I know that point is on my graph. Now what?
Mm-hmm.
I need one more point. Whenever you're graphing a linear anything, whether it's an equation or an inequality, you need 2 points. 2 points determine a line.
So would it just be the origin?
No, look at the slope. The slope is the next most important thing. In fact, the slope is the most important thing. So how do I get a slope of negative 1/3? Remember what slope is. Slope is rise over run.
Up 1 to the right 3.
Yeah, except if I go up 1 and to the right 3, I have a positive slope. Notice. In other words, that produces that line right there. Well, this is a negative slope. So you can't go to the right 3, you got to go to the left 3.
Okay.
Okay, so I'm going to go up 1 and to the left 3. I could also go down 1 and to the right 3. Okay, if I do that, I end up right about there. And the key thing here is to know whether that's positive or negative. Is that a negative slope?
That's positive.
No, that's negative.
Hmm?
Let's talk about that. let me draw a bunch of slopes, and I want you to tell me what each one is, positive or negative, okay?
Okay.
All right. What's that?
That's positive.
What's that?
That's negative.
Nope, that's still positive.
They
Notice,
cross on the middle.
notice that both of these start from lower left and go to upper right. Lower left to upper right. That's positive slope. Okay.
Okay.
If I draw that, what is that green one?
That's positive.
Correct. How about this one?
That's negative.
Right, because I go from upper left to lower right. In other words, I go down, but I go to the right. That's negative. Okay? How about this slope? Horizontal line.
That's positive.
That's 0. Horizontal lines are kind of unique, and vertical lines. What's a vertical line? What's the slope of a vertical line?
Is it all real numbers?
Undefined,
Okay.
which is another way of saying infinite. Okay? It's actually infinite. In other words, if I, here, let me draw some slopes here, just so you understand this concept of slopes is really, really important. It goes all the way to calculus. There's a slope of 1. Okay? In other words, I got to go up 1 and right 1. Up 1 and right 1. That's a slope of 1. Okay? Here's a slope of 2. I got to go up 2 and right 1. There's a slope of 4. There's a slope of 10. Notice, as I approach the vertical line, the slope gets steeper and steeper and bigger. This slope here might be 100. This slope here might be 1,000. And finally, when you hit a vertical slope, it's an infinitely large slope. So they don't like using the words infinity, so they say it's undefined. Okay? So vertical slopes are undefined, but horizontal slopes are 0. M equals 0. Okay? Now, that's a slope of 1. We know that steeper slopes are bigger numbers, but that is a slope of 1/2. So flatter slopes are slopes that are closer to horizontal. And then when you finally reach a horizontal slope, that's equal to 0.
Okay.
And it's equivalent on the other side of the y-axis. In other words, if I have a slope like that, that's a slope of -1. It's negative, but it's the same up 1 and left 1. All right, so let's go back to your problem. We've got y equal -1, y is less than -1/3 x plus 2. Well, let's graph that. I started at 2. That's the y-intercept. But now I got to go up 1, or let's go down 1 and over 3. Notice that I can do either one. I can go up 1 and left 3. That gives me the same negative slope. Or I can go down 1 and right 3. That creates a negative slope. That slope is negative 1/3. Now, should that be a solid line or a dotted line?
Dotted.
Correct. In other words, if it's less than, it's dotted. If it's less than or equal to, it's solid. So this should be a dotted line. Now the question becomes, which side of that should I shade? Above?
Below the line.
Below, exactly. In other words, the way to figure out which side, it's always above or below. It's never left or right. Okay?
Mm-hmm.
And I'll explain that in a minute. But because y is on the left side and this is the y-axis, all you have to do is find a point. You look to the y-axis. You find a point on the y-axis that's below that line. Well, there's a point. That shows you the side to shade. Okay? And when I say above or below, if I gave you this situation, where y is greater than or equal to 15x, notice the slope is 15, very steep.
Mm-hmm.
Which side of that line would I shade?
The right.
Remember, it's always above or below, never left and right.
Below.
No. Go to the y-axis. Pick a point on the y-axis that is greater than or equal to this line. Well, that point, that point, that point, that point, that point, every one of them indicates that we're in this area here, right?
Mm-hmm.
Well, even though it's tempting to say that that's to the left of the line, that's the incorrect way to think about it. Always think about it as being above or below. Okay? In other words, if I change this equation and make it less than or equal, now I would go to the y-axis and I would find a point less than this line. I'm only looking at the y-axis. So there's a point less than the line. That tells me which side to shade it. And again, that may look like the right side, but it's not. It's the bottom side. Remember, you're only looking at the y-axis, not the x-axis. Okay? What else you got?
Let's do 2y minus 4x is greater than 12. And then underneath it, y is greater than negative 4.
All right. Here's a situation where we have to graph two lines, shade each one, and whichever one or whatever area on the curve is in common, that's our area. That's the solution area. Okay? Well, let's start with the bottom. That's the easiest one to do. How do I draw the y? Always start with an equation. So you're going to graph the bottom one as if it were y equals minus 4. How do I do that?
Start at the origin.
The horizontal line, not at the origin, goes through this point, minus 4. And it's dotted because it's greater than, not greater than or equal. So that's this equation here, or not equation, but inequality. Which side of that would I shade?
Above.
Correct. So that's this whole area. And now let's go to the first inequality. In order to graph that, we have to put it into y equal mx plus b format. So let's start. What do I do as a first step? In other words,
Subtract 2.
I want to add 4x to both sides. And I put the 4x first instead of the 12 because I'm trying to get the y is greater than mx plus b format. In other words, this is our standard for any equation in the upper right here. If I can get an inequality in terms of that, then I can graph it. What's the next step here?
Find the y-intercept.
No? I've got 2y is greater than 4x plus 12. What's the next step in graphing that? I got to get it into y is greater than mx plus b. Well, I'm close. I got 2y is greater than this. How do I get it down to just y?
Divide.
By 2. If I divide everything by 2, I get y is greater than 2x plus 6. Now I know how to graph that. Where do I start?
With the y-intercept.
Which is?
6.
There's 1 point on my line. What's the slope?
2x. Well, 2.
2. Not 2x, but 2. How do I graph a slope of 2? Where's my next point?
Up 1 to the right. 2.
Actually, it's rise over run, so I got to go up 2 and to the right 1. In other words, it's a steeper slope than a 45-degree angle. Okay? So there's my line, y is greater than 2x plus 6. Which side of that line am I going to shade? And I'll shade it in green.
Below.
What's that say?
It's greater.
What does that mean?
So greater is above.
Above, exactly. So I'm finding a point above. The only thing I'm looking at is the y-axis. So I have to make sure that the y is above that line. Okay? Well, now I have the region that is in common. Well, let's see. What region is it? It's this area here. That is greater than minus 4 and greater than that line. So the solution set would lie in that area. And I haven't, first of all, it's got to be greater than minus 4, so I didn't draw that quite correctly. Hold on, let me draw it a little bit better. The solution set is there. And it doesn't end on the left. It actually goes all the way over. In other words, any point that's greater than minus 4 or above that line. Notice that this red area over here is not in my solution because it's below that line. And this area down here is not in my solution because it's below the bottom line. So when you're looking for the solution set to this, it has to be greater than one line and greater than the other line. Well, that's the area that I circled, pretty much. Now, it goes all the way to negative infinity in that direction. But when you have two inequalities like this, what you do is shade each one, and wherever the shading is coinciding, then that's your solution set.
Okay.
Okay, you got another one?
Y is less than or equal to x minus 2, and y is greater than negative 5x plus 10.
Negative 5x plus 10?
Yes.
Okay. First one's pretty easy. How do I graph it?
Would it be a horizontal line?
No? Remember what our standard, that is our standard.
Okay, so it's already in slope and intercept form.
Standard.
Yeah.
So where do we start?
With negative 2.
Right. We'll call that negative 2 right there. So that point is on our line. What's the slope? What's m?
1.
Okay, how do I draw a line that's going to have a slope of 1?
Up 1.
And?
Over 1.
Which way over? I find this universal no matter what part of the country a person is in. They always say up and over, which isn't, that does not define the slope because I could go over to the left or I could go over to the right. So you really kind of have to say up and to the right or to the left. Which is it? Remember, I need a positive slope. So I got to go up 1 and to the right 1. That gives me a positive slope. That's why it's so critical to know the difference between positive and negative slopes. Now, I could have gotten this same slope by going down 1 and left 1. And I would have had that point. And then I would have drawn a line through those 2 points. But any 2 points determine a line. So you can go up 1 and to the right 1, or you can go down 1 and to the left. Both produce a positive slope. Which side of that slope do I shade? Or which side of that line? And it is a solid line because it's less than or equal.
Below.
Correct.
Because it's less than.
Right, exactly. Is all I'm looking for is the y-axis. I'm not even talking about right or left. Never say right or left. It's always above or below the line. Okay, now let's plot the other line in green. Where do I start on it?
Talking about the next inequality?
It's also in y equal mx plus b format. So once you get it in y equal mx plus b format, it's pretty easy to graph. You start with b, the y-intercept.
So that'd be 10.
Yeah. So I'll go up here at 10. That point is on this graph. Is this going to be a dotted line or a solid line?
This is going to be a solid line.
No, it's greater than. So it's dotted. The only time you have a solid line is if it's greater than or equal or less than or equal. That's the difference between a dotted line and a solid line.
Okay.
Okay? Now, how do I find another point on this line?
Rise over run.
The slope. Slope is key. The slope is -5. How do I get a slope of -5?
Down 5.
Good.
Um,
Right or left?
left.
No, that would give me a positive slope. You see why? In other words, if I go down 5 and go left 1, I end up with that slope. That's a positive slope. I don't want a positive slope. I want a negative slope. So, to get a negative slope, I got to go down 5 and right 1, like that. I connect those 2 points with a dotted line, and that is a negative slope. Another reason why it's very important to know the difference between positive and negative slopes, because you can always figure out which way you have to go, right or left, when you're drawing your line. Now, which side of that line do I shade?
Above.
Correct, which is also to the right, correct?
Correct.
But you don't talk about right and left. It's just that when we're online like this, I want to make sure you understand that it's, in other words, the very first thing I do is find a point above it because of the greater than. Now I shade that, and that's the common area right there. Hold on. Excuse me, did that wrong. I'm going to shade the whole area in green. Now, the common area, which I'm going to put in blue, is this area here. You see why?
No.
I want the area that has both red and green in it. Well, it's this little patch right here. That is above the green line and below the black line. And it's only this area right here that satisfies both of those conditions. That's above the green line and below the black. And that's the way all of these linear inequalities work out, is you end up with a patch of space that it's pretty much impossible. This blue area over here, there's only one way to describe that area, and that's with those two inequalities. In other words, if I said to you, you tell me what this area is right there, you would have no way of describing it other than those two inequalities. That perfectly describes that area on the XY coordinate system. And of course it goes to the right and it goes down some. So it's not totally limited to what I've drawn in blue here. But it certainly doesn't go above the blue and it doesn't go to the left of the green.
So when I'm doing the rise over run, how do I know which side is positive and negative?
Always look to the y-axis. Always. In other words, on this first one, it says y is less than or equal to the line. So less than or equal is here, right?
Mm-hmm.
So I'm shading below that line, not above it. And then on the green dotted line, it says y is greater than that line. Well, so I find a point that's greater than that line. Well, that point actually covers this whole area, including the blue below. But I'm looking for the area that is in common with both lines. And that would be the area that has green and red in it. And that's the only way I know to do it is to shade it. You don't have to use different colors. In other words, I could do it like the following. One. All right, there's my two lines.
Mm-hmm.
I could use horizontal stripes or the top line, the black line. I'm going to put black stripes horizontally like that. Okay.
Mm-hmm.
Now for the bottom inequality, this one, I'm going to put vertical stripes. And I know I'm above the green line. So my vertical stripes can only go above the green line. Well, where do I have both horizontal and vertical green stripes? That area right there. Or I've just shaded red.
Okay.
Okay. Ashley, it's been nice talking to you again. I hope I've been of some help.
Yes.
Good. And hope to talk to you again.
Okay. Will I get to save this?
I'm sorry, what?
Will I get to save this, or we just do it?
Will you get what?
To save it.
Yeah, you'll get a recording of it.
Okay.
It won't probably, it'll take my computer an hour to process it. I'll put it up by tomorrow morning. And you still have the link to go to watch these?
Yes.
Okay. If you check it in the morning, you'll find it, and it'll have your initials, Ashley Crosby. And in fact,
Okay.
it'll have Ashley Crosby 11, 12, 16 as your first two initials and the date. And that's
Okay.
the name of your file. And it'll say something like online algebra, AC 111216. It'll be the top one. You're my last session for tonight, so it'll be the first one on my channel
Okay.
tomorrow morning.
Alrighty.
Okay?
Thanks for your help.
You're welcome. Talk to you later.
Bye.
Bye-bye.